Okay, everyone. So I know it's kind of late, but I just wanted to make a little tutorial about how to do these Excel graphs because when I opened Excel, I kind of got lost myself. So let's go through this. So I know the first lab, no, sorry, not the first lab, the first titration experiment, things went a little rough. Probably things didn't go as planned, and that's okay. I mean, you only had um, measuring out water the previous week, so it was kind of hard to expect everyone to ace this experiment. That would have been like the goal, or if everything went smoothly. But oftentimes in chem lab, that's not the case. So we have to kind of just be prepared for that. So for this lab, we're going to be lenient. I'm going to be flexible. I gave everyone data, complete as much as the post up as you can. If there's any issues, like if you need retrials, my recommendation is just duplicate all the data, and just so that'll make your average. And the concentration you determine based on this data, you should just put that as the concentration of your sodium hydroxide solution. And from that data, determine the concentration of HCl, and you're going to put that as your data for the HCl solution you made as well. So if there's any confusions about that, I'll remind you in lab next week. Sorry, not next week, this Friday, when we do the second titration experiment with titration of a weak acid, acetic acid. But in this lab, I'm going to kind of, be more of a boot camp sergeant, going to kind of drill you guys to go do this quick. So because we only have 3 hours, and in the real world, when you go maybe work at a company or an industry or something, you can't dilly-dally and like take forever to do a task that should have taken maybe just a fraction of the time. So it's okay to make mistakes, but we need to improve our skills and learn how to do these things in a timely fashion. And I'm here to guide you. And I know the last week was kind of hectic. Everyone was running everywhere. A lot of people. I was running everywhere trying to attend to many pairs as possible. And that kind of got a little overwhelming. And it didn't help that that things weren't really labeled in terms of where to find some chemicals, because I assumed everything would be in the trays, but that's my bad. So I'll know where everything is for this next experiment. You can count on that. But yeah, don't be afraid to give me negative feedback for the lack of organization last week. I take full responsibility for that. Okay, so for the titration experiment, we have our data, right? So if we're looking at this screen here, the sodium hydroxide, you should have calculated this from the difference between your burette readings. So you can't just look at the burette and estimate the mils that was added. You should record the initial value, then the value you stopped at. And the difference here, the difference of those initial and final readings will be these values all in here at every step, at every point where you stopped. So record all of those values. Your pH should also be the same there. So people who got data actually got through one titration, you'll put your volume that you added by taking the difference of the burette readings, and then the pH, you'll insert the pH you read from the pH meter. So in here, in this column, we want equals difference. So for example, burette reading, so where you stopped, minus burette reading where you started from. So you're going to record your initial and final values. It might be better to say the volume equals final burette reading minus the initial burette reading. So that's going to be your volume you delivered, okay? All right. So if we just take these two values, we will get the titration curve. So let's just show that right now. So we're going to highlight our columns and we're going to click insert, go to chart right here, and you're going to choose XY scatter. So we want an XY scatter chart. When you get your charts out, they must be a full page. I don't want to see Excel spreadsheets with your data here and your chart right next to it, very small. On one page, I don't want that. So I set up the drive folder so you don't have to print anything out. So you can say paper. So you could just highlight this, and go to save, not saved as, but I think you can export things or save as right here. And we're going to save as, or there should be a save as option. This has been a while. Let's figure this out. Okay, so select chart. I guess you could save as picture as well, a PDF or something like that. So you could, I think you could do that for the charts. So they should be one single page. So I should have three pages of charts from each of you. You can combine them to one PDF file, but they should be one full page per chart or per graph. Okay, so let's edit here. So see here, my data it's pretty good. You're representing the titration curve here. So we could click on the data, and then we can go to here. Click on the data points, so they're all highlighted like so, and then we can go to line. So go to this bucket thing here, icon, and go to line and put solid line. Okay. So if you try to insert a chart and you put line graph, that will give you a chart that doesn't look like this. So don't do line graph. Okay. So these graphs are pretty much what we're going for in this experiment. So they're going to be worth some points. So you should do a good job on it. So XY scatter. Don't do any other of these, like waterfall. I don't even know what that means. What is waterfall? I'm just curious right now. See, we get blank chart, so don't submit that. All right, so let's leave that. Okay, so now we want to make our graph look more presentable. Okay, so we want to probably shorten these units here, so we can say so let's edit this. Actually, this is pretty good. We don't need to edit really this this y-axis, and x-axis is pretty good as well, but we could probably cut off this area because there's no data points going to past 30 mils. So we could say change this to 30.0. Okay, but we should, yeah, there we go. All right, so we exit there. See, the chart moved right there. So that's all right. And we could actually edit this one too. It starts at 5 mils, right? So we could edit the minimum point to be 5 mils. Okay, if I can click on it. The axis options here doesn't have any options really. Okay, minimum we could put 5 mils. So no need to have it starting at 0 because that's just space that's not being used. Okay, so this looks more presentable now. Let's kind of increase the tick markings here, the data points. Can I increase the transparency here? No, I don't want the line. I want the data points. The data points. The markers, I guess. Markers. Let's see here. There we go. So let's make them a little bit bigger. Okay. Probably should be a little bit bigger, larger than that. Oh, this is the line, sorry. I want the markers. Where's the markers? Markers again. Let's. Okay, so that looks a little better. Good. Now, lastly, let's make this font a little bigger here. The tick marks. We don't need really tick marks here, so let's not do that. Labels. I guess we can't change the font. I guess that will be increased later on. Okay. All right, so now let's talk about titles. So the title you probably should use is probably HCL, titration, curve. Okay, we want to give a descriptive title, volume of sodium hydroxide versus pH. So when we read graphs, it's always the x-axis versus the y-axis. So your independent variable versus your dependent variable. So the volume of sodium hydroxide doesn't depend on the pH, right? There's no relationship there, but the pH is dependent on how much sodium hydroxide you add. So that's why we put y as the dependent variable, x independent. Okay, so let's change this font here. Let's increase a little bit, 24. Make it a little bit bigger. And then these fonts here, I think we could change them, right? I'm trying to change it right here. So let's make it like 16. And this font's 16 too. All right, good. So now it's looking a little bit better. Okay. So let's edit our y-axis. So our label, we should give it a label. If I could figure out where it goes. Okay, labels, next axis, axis options, text options, text fill. Huh, I forgot how to label it. Let's see, axis values in reverse order, labels, doesn't really say. Oh, I see. We should probably highlight this value too. So when we're making a graph, let's make sure we highlight the name. Okay. All right. Okay. It kind of changed a bit. Let's see here. Okay, so maybe we don't need that. I was under the impression you can add a label. Axis options, here we go. Oops, sorry. How you do the label? Okay. Format plot area. Oh, I see. Yeah, it's been a while. So how do I change this here? Fill, properties, chart options, no, text options, not really. Text options, no. Okay. Okay. All right, so check the data source. Oh, here we go. Here we go, the labels. Or not. Let's see this. Volume of sodium hydroxide added. What does that do? Nothing. Okay. Very well. I did not mean to take this much time talking about axes. Text direction doesn't even have text. So I don't know what they're talking about. Okay. Ironically, I will have to go look at the instructions in the manual here. Okay, give me a sec. because it's not self-explanatory. Okay, here we go. Axis titles. Okay. Okay, it says click on the chart and put add on the plus button to insert chart. Oh, here, add chart element. Sorry. Okay, we go here. Axis tiles. They made this so complicated now. I don't know why. There we go. Okay. All right, we're going to put sodium hydroxide, the amount that was added. So if you can guess, I'm not a PC person. I think these instructions were made on a PC. I'm more of a Mac person. Okay, volume. Come on. Volume of sodium hydroxide added. Okay, so we need to put descriptive titles. Don't leave the titles out. They're important so we know what you're measuring. On this graph, we don't really know the units. So we need to put those units in there. Okay. So now we take this. Well, that's a bummer. Why is it there? Okay, hold on. Title options? No. Chart options. Okay. All right, we had this before. Okay, let's go back to chart options. Where was that? Data? No. Man, this is so complicated. Okay, axes. Data tables, no. Data labels? Okay, I just changed it. Oh, let's go back. How do we position the chart? How do we position? I think we had this before. Oh, we click here. Okay. Here we go, axes options. Bottom center, no. Vertical alignment. Okay, I don't know how we modify. Okay, where's the labels? Here we go. Next axis, low. Label position? It's not even going. None? Oh, sorry. Let's do high. No, that doesn't make sense. Next axis. Okay. But how do we move this down? Makes no sense. Okay. There we go. Man, that took a while. Sorry. Okay. Now let's go back to the chart area and do the other axis. Let's do the other axis. Okay, chart design. Yeah, okay, now we're going to add the primary vertical, and that's going to be pH. Okay, pH level or just pH. Let's make that now like 16. This font was 16. So let's make that 16. There we go. Well, that's not 16. This is like what? What's this size? Oh, 20. Let's do 20. All right, there you go. pH level versus volume of hydroxide. Okay, so that's our curve for the titration. So you have a volume, pH level, looks pretty good. Okay, so let's move this graph out of view now. So we got the graph. Oops. Okay, so let's just shrink it a bit, but you'll print whole pages of this graph. So you'll print whole pages of this graph for your post lab. Okay, so just make this graph look nice and pretty, and then make it a full page, and you're good. Okay, so now we have to calculate all these terms. So VM, we're going to calculate VM, and that's the midpoint between like two volumes. So we're going to calculate VM. So here we go, and VM is the midpoint between volumes of sodium hydroxide. So we can express this calculation using the equation VI plus VI plus 1. Those values, how do you get those values? What's VI and what's VI plus 1? Okay, so VI is just the initial volume you added. So the volume that you started with, the volume hydroxide that started the titration, V 5 mils. So you're going to do put in. So when we write equations to solve for use Excel as a calculator, we just put equals, then we put in an equation. So we're going to put in parentheses VI. So VI is going to be my 5 mils. A3 plus VI plus 1 is the second volume of NaOH added. So we're going to put 10 here. A4, close parentheses, divide by 2, and then we should get a value of 7.5 milliliters. Okay, so then to make our lives a little bit easier, we're going to highlight, or we're going to select this column, going to come to this corner, right, left hand, lower right hand corner, and when we see this cross icon here, we're going to click and drag all the way to the end and then release the click and drag, release the click, and then we see here all our values have been calculated for us. So that's pretty efficient. Okay. So just make sure that the equation is correct for all of the values. We actually don't want this last value because you can't, there's no way to calculate for this value because that's where it ends. So we would leave this one blank. So just make sure the calculations are all correct. You see here, it's from my A3 plus A4 gives me that. This one goes a step further, A4, A5. So just make sure they're all correct. But if you have the equation correct here, you're all good. You don't really need to check it. Okay, so that's VM. Now we need to calculate D1. Okay, so D1 is going to be, all right, so okay, so now we're going to calculate D1. D1 is the first derivative. So that's the first derivative of our measurements. So it's going to be, we're going to find the rate of change in pH versus NaOH added. So I didn't know this was a trick you could use. I might have to borrow this information or kind of use this information for my other chemistry classes to find the actual midpoint. That's pretty cool. Kudos to Dr. Brian Enderle. I think he did his PhD in chemical engineering, so he knows his stuff. He knows his stuff. All right. So this is very cool. Okay, so we're going to put our equation here. We're going to put, if you read in the lab manual, it says PHL plus 1 or I plus 1 minus PHI over VI plus 1 minus VI. So, okay, all right. So we're going to put, so it's kind of the same thing. It's going to be the pH. So in this case, PHI is going to be the pH of the second value right here, minus the initial pH divided by the second volume of sodium hydroxide added, in this case, right there. But in this case, we put the second volume minus the initial volume right there, and then we just press equal, and we should get a value of 0.04. Okay, so that's all you do. So to reiterate, we do the first pH, the second pH minus the first pH divided by the second volume over the initial volume. So you click enter, that's what you get. And now we drag all our values here, and we end up with a column like this. Okay, so that looks pretty good. All right, so that's the first derivative. Okay, so now let's plot it. So we're going to plot the midpoint volumes. So we're going to plot the midpoint volumes versus the first derivative. Okay, so the first derivative. So the equivalence point, this will tell you the equivalence point, but let's graph it first. So insert chart, XY scatter. And you see here, we get this kind of nice looking graph that has a kind of a maximum point here. So we're going to put a solid line. And what this tells us is that the maximum point on this line is our equivalence point. So this derivative kind of generates our curve that we generated, the pH and sodium hydroxide graph. And it points to us what the equivalence point should be. So that's pretty cool. Okay, so let's improve the size of these dots first. So this is the line. I want the data points here. Okay, so I'm clicking on the data points, I believe. Am I clicking on the data points? Doesn't seem to be working. Okay, maybe I'm not on the data points here. Okay, so now how do I change up the marker? Sorry, it's supposed to be a marker. I guess it comes to a point where you can't increase the size of the marker. All right, there we go. Okay, so let's edit our chart title. We're going to just say the first derivative. No need to be any more descriptive than that. Doesn't matter really. Okay, just don't leave it blank. All right, so let's fix our axes here. So our axes will stay pretty much the same except for the x-axis. So let's insert an axis here. Chart design, let's insert the primary and the primary vertical. This will just be labeled D1, first derivative. Let's increase this font size here. And then the axis tile for this, the bottom position will be the same. Volume of sodium hydroxide added in milliliters. So make sure you put that milliliters in parentheses because we need to know the units that we measure our volume in. Let's make that 18. Okay, good. All right. So let's edit now our graphs here. So we're going to make this, the minimum is -5, good. And the maximum, let's make it 35. That's pretty good. So that's all good here. Let's actually, can we edit the labels? Display units. We're just going to do hundreds. No, in this case, thousands. No, none. We want none actually. But I don't want those. I want those numbers, decimal places. Let's put no decimal places in this case. Okay, so no decimal places. Because that's just how it is in your manual. So let's just be consistent here. And then this position, let's change the axis options here. We're going to label it from 5 to 30 again. Okay. I can't even select it. Okay. Oh, here we go. All right, so 30, and the minimum unit is going to be 5.0. There we go. Okay, looks pretty good. We don't actually need, again, the numbers. Let's put no decimal places just to make it a little bit more cleaner. There we go. And let's change the font size now because we need a little bit bigger here. All right, there we go. But yeah, it looks pretty good now. And then 12, 14 again. Here we go. There we go. All right. So this first derivative, the highest point is your equivalence point. So you know, compare that to what you did in your calculations for the average molarity, where you found the equivalence point and determined the concentration of HCl. So kind of see how that compares to your equivalence point. Okay, so your equivalence point should be at 30.9 mils. No, sorry, not 30.9, but 30.9. This is at the position of 19, or sorry, this position here. That's the midpoint. So it's the volume is at 19.65. So that would be the volume you would want to use. So this point right here. So in this case, we have a volume of 19.65 mils, and the derivative, that value is the Y value. So we'll use this value as the volume for your equivalence point. All right. All right. So that's pretty cool. So now we're going to do a second derivative. Okay, so those are for our last two columns of data that we're going to calculate. So I'm going to move this aside now, over a bit out of view here. If you want, you could just copy these sheets to a different spreadsheet as well, just to keep it nice and clean or nice and organized here. Okay. All right. So we could rename this as, first derivative graph. And then second sheet, we can rename it as the titration curve graph. Okay. Then we can just delete those here. Delete. Okay, because if we highlight this, it'll show us, well, you can't see it, but it would show us the things that are highlighted if it was on the same sheet. But let's just keep them as separate things right now. Okay, now to calculate VD, V/D. So this is the derivative midpoint volume. So you can think of it as the midpoint volume, but from the derivative, if we took the derivative. So it's calculated the same way as we calculate VM, but instead of finding the volumes between sodium hydroxide, the original volumes, we're going to take the midpoint, the midpoint values, the middle of the midpoint values. So the midpoint between the VM values, okay? So the equation here is VDI equals VMI plus VMI plus 1 over 2. So in this case, we would put equals VM1 or I initial plus VMI plus 1, the second volume divided by 2. Okay, so that would be our first value. 10.00 milliliters. Then we just do the same thing, automatically calculate the rest of the columns. But notice we can't do the last column because that's where the VM volumes end. So we have to go one up, one above that. There we go. So now we have all our values here. It looks pretty good. Okay, so that's VD. So that's how you would calculate VD. To reiterate, we take the first VM volume plus the second divided by 2, and then you're going to do that same process down the list, but don't do it individual calculations. Just do it as a batch. Okay, so press enter. Here we go. All right, now to calculate D2. Next, we're going to calculate. Okay, VM. All right, now we calculate the values for the second forward divided difference, D2. So this is what we call the second derivative. If the first one, the first derivative, we're going to take the divided difference between those values, between the first difference and the VM volume. So we're going to, for the second, so D2, second derivative. So we're going, instead of pH, so in the first derivative, we found the rate of change in the pH, or in the volumes, right? No, let's go back here. It was the pH, but now we're going to take it from the D1 values. Okay, so we're going to take, so our equation here equals D1. So the D1 minus 1. So you don't want a negative number. So the first initial plus 1. So the second value minus the initial value divided by the second VM volume minus the initial VM volume. Okay, then you push equals, and then you get a value of 0.01. All right, now for our data, we're going to do it like so and go all the way to the end here. And then we see here that those are all of our values. So some are in fact negative. But if you were to do it the other way around, it wouldn't make sense because we're taking the difference between two values. So usually the second one appears first. Okay, so make sure you do the second value first, like so. Okay, so I think we're ready to graph our final graph here. So we're going to graph, all right. Okay, so make sure you don't apply this data to the last two rows. You'll get some weird data points. So they'll do that. All right, so we're going to generate the second derivative here by taking the VD values and the D2 values and do a scatter plot. So let's do that right now. Scatter plot, data, sorry, insert data here. Let's see, I'm even losing my mind. Okay, scatter plot. All right, so we don't need those data no more. So let's just do, look, it looks kind of weird, right? What does this mean? Okay, there we go. So then we're going to do line here, solid line, and it looks like an ectocardiogram. Zoop. All right. So how do we read this graph? So this graph is how you read it is the point where it crosses. So the point, the value at which the plot passes through the x-axis, that's where your the point where it crosses the x-axis. So at this point here, if we look right here, at 0 or so the point where it crosses the x-axis, that would be this point. But so the closest thing to that point, I think, is this graph here. Okay. All right, so the point here, so the point at which the plot crosses the x-axis, that's the volume you want to read. So, so this point is actually -54. So -54, that's pretty much the volume. So -54, that's D2. The volume is where this lines up. So that's 19.70. So remember from the second graph, we said 19.65 was our equivalence point. So that's pretty good. So it's actually 19.77. So we go to this point right here. This point is 19.65. So that maximum point. And now we use a second derivative. We found this point right here is almost, see, this is where the point where it crosses. And it lines up pretty well here. So that's going to be 19.70. So 19.7 mils. Okay, so let's wrap up this graph here. So let's change our units. We're going to make it 5 and then up to 30. So 5 here, numbers, no decimal points. Okay. Don't worry if your labels are kind of messy and are blocked by the graph. That's perfectly fine. Our title here we're going to make is, so our chart title, if I can highlight it, is going to be second derivative. And you see here, by doing these manipulations with our data, we can actually determine accurately what our endpoint should be. This is the power of math and data analysis. Okay. So our Y volume should be the same. Hold on, let me just make sure I got this correct. Yep. Okay. So let's put a value here. We're going to do chart design, add an axis title, primary horizontal, primary vertical. There we go. So we're going to label this still volume of sodium hydroxide added in milliliters because we're still using the volumes of sodium hydroxide. Okay, so our home, we're going to make it a little bit bigger. So let's do that. And then let's fix our Y values here. So our value should be D2. We're not going to put any decimals though. So we're going to do from -220. Let's do -220. It depends on what your data looks like, but just make sure it fits the whole graph. And then the maximum 280 is pretty good. Okay. And then, you know, the units don't have to be exact. You know, you don't have to do the exact units here, or sorry, you don't need to worry about major and minor units between the values on the axis. So that's okay. So let's remove the decimal points. That is not necessary. And then lastly, let's change this font size. And then the axis style here would be D2. So see, calculus does have some usefulness to it. Okay, sorry for my bed here, everyone. Okay. So you see here, that point, that value is where we found our equivalence point. So this helps you find exactly what the equivalence point should be. So sometimes the equivalence point and the endpoint where the titration, changed color or gave you an indication that it was over, sometimes they can be different because sometimes an indicator, it has to be basic. So basic to change color. So that would mean that you pass the point where moles of acid equals moles of base. So you have to, then that would mean moles of base is now greater than moles of acid. So that would not be your true equivalence point. So they're different, they are different terms. Sometimes they mean the same thing, but sometimes they don't. So in our cases, they don't, because phenolphthalein changes color in basic solution. And if we have equal amounts of strong acid, strong base, the pH should remain 7, not be basic. Okay. All right. So that is how we do the graphs. I know they can look a little complicated, but just know your second derivative should look like a inverted peak, inverted, like an echocardiogram, pretty much like one of those weird heart signal, measuring the electrical activity. Looks like one of those electrocardiograms. And then the first derivative should look like a just a single peak. Okay, so you don't get a single peak, you did something wrong, and you should go back and fix it. If you have any questions, you can ask me. And your titration curve should look like a curve like this. If anyone's taken biology, it looks like one of those allosteric graphs. So like enzymes have these what we call allosteric states, and it has to do with like an open state or a closed state. I don't know if you guys heard of it, but this kind of looks like an S. So it looks more like an S shape. Okay, so you go to a point where the pH is slightly changing. Then once you reacted all the acid, it's going to spike up it's going to spike up, and this region is where this is what we call the inflection point. So this inflection point tells us that the inflection point tells you that there's a rapid change in pH, and that happens at the equivalence point. So after that, you reach a point where you're high in pH, and then you slowly start increasing and flatlining towards the pH value of the strong base, which is around 12 or 13. But in this case, I think it's 12. The pH of sodium hydroxide solution, usually 12. Okay, so that's how you do the graphs. If there's any questions on how to do the error analysis, standard deviation, the instructions in the manual should be pretty straightforward, but you just put in your data, and you just, for example, if I had a data set, I would do, and I want to find standard deviation, I would do STD. So that's standard deviation. And then I would highlight my data points for data that I want to take the standard deviation of. So for example, if you have concentration, you're going to take the 3 concentration values. For example, let's do this. So say it's like 0.2021, 0.02, 0.2150, and how about 0.205? Okay, so say those are my concentrations. So concentrations of HCl. Now, if I want to calculate standard deviation, I would do STD, standard deviation. Oops, don't press enter actually. Highlight it. Then highlight these columns here, and then I will hit enter, and it calculates my standard deviation for me. Okay, so that's pretty useful. You can also use average. So if I want to take the average of the molarity, I will click the average button and then do that. Oops. Activated my hiragana keyboard. Sorry about that. Should have saw that. Let's erase that. Equal average. So if you press enter, don't do that. It thinks you're putting in an equation, and if you do that, you won't spit out this. So make sure you click on that, highlight this, press enter. There we go. That's your average molarity. We probably want to put it to like 3 sig figs or something. So let's move the decimal point back. Like that. All right. So here's the average molarity, and here's your standard deviation if you were to do those 3 trials. All right. So if there's any other questions, hit me up an email. But submit these before lab in your Google Drive folders. If you don't have access to your folder or haven't seen that email from me, please let me know before the due date. Okay, so that's experiment. That's experiment 4, strong acid, strong base, titrations, how to do the graphs. Okay, so that's the last part of the post lab. Do not put it off. It'll take some time. You don't want to rush it. And if the graphs are not nice and beautiful like this, I will definitely take off points for cosmetics. I don't want to, but if the graph should represent, your data and its best form. So if you don't present it well, others won't take you seriously, and you'll kind of be laughed at. So don't do that. So make sure you present your best work. Okay, so everyone. Hope this helps. If it doesn't help, that's okay. You're on your A game. I appreciate that. Great job. Okay, but I will see you on Friday for discussion and then for lab. All right, take care.